You have one? Oh, it's fine. Okay, never mind then. So, okay, whatever. So then I'll get right into what we were going to do. So, what was the thing that we left on? Let me check that out real quick. So we have this. We're gonna start. We have, oh, oh, okay, right. So there's but okay. So let's troubleshoot through this error. This is actually very good to do because that is like what I want you to take from this is like how I solve this type of errors. Oh, change. Yeah. So for example, here I have an error. So just for sometimes. So well, the thing is about interpreting how the error is affecting you, right? So for example, so let's look at this thing here. So the error is here at the end, and it says index error list index out of range. So what do you make of that? So we have a the error there, the error thing down there says. Let me make this bigger. No, that's fine. So do you see it now? Easier to see. So the oh no. Yeah. Okay. So let's go part by part. Okay. So list index out of range. What do you guys make of just that sentence? Okay. Yeah. Yeah, yeah. So we are. So what's an index? So when you think of a book and the book has an index, what does that say? Yes. So it's like a list. It's a list that is a list of numbered items, right? That say like, okay, if you want to review of this book, like in this book we're talking about, I don't know, cooking, let's say, and you want to see where the cakes are, you go to page 250. You go want to see where the Italian stuff is, go to page 300. Okay, so it's just a list that tells you also. So out of range. So let's say this book is 400 pages, right? And we put an index there that says like, oh, if you want to look at the Chinese food, you go to page 600. The book is only 500 pages. You see? So that is kind of what it's being said there, saying that list index is out of range, saying that we're looking for yes. So in our case, what could that mean? So, and then we look at the next part, okay? We're looking at point self.trail. So what is self.trail? Yes. So that, if we remember, that's like the pirate map. So hold on, I want to do a little experiment here on the, I want to see how this looks on the board here. Let's see. Huh, yeah, well, we'll see. It depends on the light. So what is right? So we have an island, right? We have an island, and we have a pirate, Mr. Pirate here, saying this again. Yeah, that looks nice. Yeah, that looks nice enough. Okay, pirate here, and the pirate wants to bury his treasure somewhere. You know, we have a mountain in the mirror, mountain with the skull, because that's how all evil pirate legends goes. There is a palm tree that's kind of crooked, funny over here. There is the old shack that is all destroyed, and there's a windmill here, you know. So, and he wants to bury the treasure somehow. Here's the pirate with his little pirate hat, little plume, you know, his little sword. Uh, so he wants to bury his treasure somewhere, That looks nice enough. So he starts walking, right? But he knows that he starts walking, you know, and he doesn't record his trail. He will get lost and he will remember where he buried the treasure. So every time he starts walking, he starts putting down where he went, right? And how does he store that? He stores that in a list of the steps that he took. So the first step that he takes, he starts from 0, 0, right? At coordinate 0, 0. Then he goes a bit to the right. So that means we're upping the x value a little bit. Uh, for another. Is that in the right? Yeah. So this is a 1, 0, comma. And then in the other one, so let me make this a bit more computer-like. Then,
Wait, so in the array you have x, y?
yes, remember that. So yeah, the array, yeah, that's important to understand. The array is xy, so it's an array of arrays. It's a two-dimensional array. Yeah, why? Because each data point has two values, right? So the next one, you see that I went down a little bit, and also went to the right and went down a little bit. So that would make me go. I went to the right a little bit, and then I went down a little bit. So -1, right? And then in this next one, well, actually 0, 0, and then the last one, I just went to the right again without going down anymore. So I go 3, comma, -1. And then I keep adding to that list, right? So for each of these sublists, the index is always 0, 1, 0, 1, 0, 1, 0, 1. That's always the index, 0x, 1 is y, right? And then 1, 2, 3, 1. I get the feeling, actually, nothing like audio capture is fine.
But like I like in the previous program I had to see a 2D array. It's like something new.
No, no, it's always been, remember, this. So but the way that okay, so the thing is that in for the Python thing, where how does your append look like? So let's take a look at it because the append, right? The append looks like we're doing this, right? So here x, y, and then we have number 0, number.
Oh, so when you append, it's
But look that no. Append is just it could be any item, okay? Could be any item. In this case, the item is two-dimensional because the item has two items inside of it. Make sense?
Yeah.
So in other languages, you would have to define things like this. In Python, you don't, but whatever. So remember that, like, so when you put it inside the parentheses, right? It could be just one item. It could be just like a number.
Yeah.
So for example, in here I'm adding 1. In here I'm adding something that is also in parentheses. So I'm adding two things. Make sense? So if you see the append in the append, I'm pretty sure it's basically append list dot append this thing, right? So that's why it's two-dimensional.
Yeah, it's like actually write like I don't know like double brackets like to make a 2D array. They have
In other languages, yes, you would have something like that. In Python, you don't, so it makes it a little bit easier. But but you are correct that yeah, there has always been a 2D array. This thing.
Oh, okay.
The data structure is
It's like a separate.
it is an array. Yeah, and truthfully, yeah, it is just an array, right? Well, let's be careful with that way of saying it.
Yeah.
For Python purposes, it is just an array. In reality, there's more stuff going under the hood, but that's what Python does. It abstracts a lot of this stuff. If you were doing C++, then you would have to define all of this stuff, right? Okay, so that does that, right? And we have all those items. So now, when we are, so you see that list up there, that's the list that we're looking at. So let me go back to screen. That's the list we're looking at. So that's the list that it is said here that has the error, right? So saying that we are out of the range. Now, how does that how does that change, or like how do we describe that, or how do we look into that? Because maybe you're running someone else's code, and in case of Ezra, he hasn't even seen this, so it's good for us to go. So like I way to find it is, look, is snake.py line 15. Okay, so I can go to the snake file, right, and then line 15. So line 15 right here. Okay, so I already know kind of what this error is about, but I'm gonna try to make it as if I don't know about any of this, so I can like kind of describe it better to you. So I know that basically what I'm doing is, let me go back to the other one. There. I know what I'm doing is that I have these many, three, four, like two, four, right? I know that I have these many items, right? But when I request the item, I'm requesting item five, okay? So I have all these items and and I'm looking for item five, right? And there's nothing here, right? So that's why that error happens, okay? So, but also think about how the list grows, okay? So the list grows dynamically, right? So at the beginning of the list, I have 0 items. The list begins like this, right? 0 items inside of it. And then in the first iteration, right, the list acquires an item, right? X, Y. So this is like the game has run 1/6 of a second, right? And I have one thing inside of my array. Now, in the third one, now I have, now we'll have 2 items on it, right? Right? I have more items on it, right? So, and I have done something that should dynamically pick which ones I want, right? But that system is not working. So now we can figure out what is not working about the system. So let's look into that. All right. Who's messaging? Sorry. Oh boy, I'll have to deal with it later. Someone needs something from me. Okay. Here. So
What were like the set value, the length,
set value of the length.
like sneaky length?
It could be. So let's look into this. Let's look into this logic, okay? So we have the draw trail, okay? So remember that when I'm doing this draw trail, I'm overriding the previous draw trail, which is just like does everything whatever. So for example, if I get rid of this and I run the game, it should all work, right? But it's not what I truly want. So oops. Why am I getting so many calls? Oh, make sure to run it on the main file. There you go. And you see it's drawing the thing, it's all nice. And it even shows the acceleration, you see? Like in here, you can see that the acceleration at the top of the screen, right? Like it draws them, right? Very close together here. And then they start to be more and more separate. That means acceleration, right? Yeah. Because at the beginning they're going slowly, so and the interval, the time that they get graphed is the same, and then they start to go slowly, right? I mean, to start going faster, so the separation is greater, right? So we can appreciate all that there. But what we want is that it lives like a snake trail, right? That these guys start to delete after a while. So that seems to work. So now we're trying to override that method into a different method. So let's take a look at that. So now, well, voice crack. So first thing that I'm saying here is if the length of the trail it is greater than 6, meaning that I have more than 6 items in my
Sorry.
no. So if I have more than 6 items in my trail, then I will start. because I don't want to start doing the trail if I don't have enough items to fill out the list. Okay, that's a cop out way of doing it, but whatever. So, but that's what this means. This means that I just won't start drawing the list until I have enough items to go through the list. Then I go for x in range self dot snake length. So for x in range self dot snake length. So what this means is for value x in snake length. So this is just 5, okay? So that is going to be changing depending if like you grab something. Remember that we said that if the snake eats something, that number should go up, right? Because your length is going to be greater, right? So what I'm saying here is that in this array, in this current array, I want to only to make I want uh, to make a loop that will only last for how much the snake is long. Okay, so let me go through this because this is how we probably will end up solving this little thing. So let me erase this because we don't need this anymore. How much the snake is long? All right, so if the snake length, right, and this could be like your points in the game, right? Length is equal to 5, okay? This loop will happen 5 times, right?
Right.
It's gonna happen 5 times, right? And what should I do with this loop? And also I have a counter. So like the counter goes from 0 to 5, okay? So 0. So every time this loop happens, I have a different uh, number here. So 0, 1, 2, 3, 4, and 5. Wow, what the hell? How do you write 5 lines? Okay, there you go. So what I need to do is every time that this loop happens, I use this number correctly to achieve my purpose. And what is my purpose? Is that I only want to graph the last 5 items of the snake. Okay? So I have a very long list, okay, that goes from 1 to a quintillion thousand, you know? So from 1 to basically infinity, okay? How do I make it? Well, actually, not from 1, my bad. From zero to basically infinity. How do I make it that per every single iteration, I only grab the last five, the last 5 items in the array? How do I do that?
You subtract over 6, right? Is that what you're trying to do?
So let's try to think about you subtract to the length. So at every point in time, we will have a length. So let's say that our current length is, I don't know, 80. Okay. What should I do to 80 if I have a number that is from zero to 5? I have a number from 0 to 5, and I have a number 80. How do I go from 0 to 5 to grab this whole thing?
Uh, so like, what do you mean, like 80? Like
80 is the oh okay. So 80 is the current length of the whole list. So the list right now has 80 items. Okay, and I only want the last 5 items. keep in mind this type of questions here is kind of what like you heard about like the algorithm interviews. This is it.
It's like a
Yes. So this, for example, we're already getting into this type of stuff. This is pretty advanced, but like you don't know need like linear algebra. We can solve this logically, but let's try. We just gotta understand what things we have and try to solve that problem. Okay. So we have a number. We have a number that we can use that is going to be from 0 to 5. So, I mean, it's easier if I do this, but know that it's basically that 0, 1, 2, 3, 4, 5. Okay? And I want the last 5 items of a 80 item list. How do I do that?
last 5 items.
Yes.
So the last five items are 80, right?
Yeah.
I mean, I was gonna say like you would divide, but I don't think that makes sense.
What about if you say that 80 is the current one, so you make I wouldn't say a formula, but you say
It is a form, basically.
that find the absolute value of 5 to the current number that we have in the list.
What would that mean? The absolute value of 5?
So let's say you want to find the absolute, what's the absolute of 5 to 0, right? That would be, well, if you have -5 in the absolute value, the answer would be 5 because it's 5 away from 0. So instead of assigning 0 being the number that we're looking for, we have 80 be that number and say include only 5 uh, digits from the, uh, include only 5 absolute value of the current number.
5 absolute value of the current number. This,
Would
let me see if I understand what you're saying. So, 5, so we have 80 as an absolute, that's what you mean by the absolute number?
Well, the absolute number is the number that we're currently on. So
Okay.
it eventually always changes. So you would
Yes.
say that you assign the absolute value to be the current number.
Okay. Yes.
So then you want to then look for 5. What is always only include numbers that are less than 5 away from the absolute value.
I think you're completely correct. Yes, that's yeah, and I think that's kind of the look. Yeah. So, but yes. So, but now last part from what you have. Yeah. So you have that's what this part means. Yes. So the absolute you're like the values that are lesser than 5. Yes, you're correct there. But now, how do we implement that into this? Like, how do we? So now keep in mind that each of these numbers has an index, right? So this has index 80. That's our last index. Then what is before 80? 79, right? Because it's not going to fit. But 79, oh my God. Let me make this a little bit bigger so it actually fits. Maybe give myself too little space here. So 80.
So like 80 to like 75, 70, 65, 60. Is that what you mean?
Let me see if I understand what you're saying. 77, 76. 75, right? Man, this looks looks like it's almost the same number, right? So we have all these indexes, right? And we want all of these numbers, right? So you have like the precise mathematical formula right now. Perfect. So from but now how do we well you have the formula of how to describe the thing, but how do we actually implement it? That's the next thing. So how do I have for every iteration of that, how do I have these numbers?
How do you get those values?
Yeah,
You're subtracting, no?
that's it. Yeah. So basically you just do 80 minus, so you have 80 minus at some point is gonna be 0, so you have 80. So 80 minus 1 gives you 79, and so on. That will give you the 5 values you need. Okay? So that is what we are trying to accomplish in the algorithm that we did here. It's badly done so much.
6, wait, no, no.
I can talk about it. So, this is
Underscores.
So yes, so you want the last five values, right? So, but we want the values that are lesser than five. Okay, less than that five from the end. Okay, so
So that's when the loop.
yeah, because if this thing grows, right? What's gonna grow to is the size of how much far we go back. So in the case, this will be 0, 1, 2, 3. Oh, jeez. Let me put this in the right way. 0, 1, 2, 3, 4, and 5 in our way would not count because we are lesser, not greater. Not, lesser, not equal. So when equal to 5, this one won't count. So we'll just get the last, and keep in mind this, the last 5 items, even though we don't count 5. Why?
Zeros count.
Exactly. Yeah, because zeros counted, right? So
Oh,
yeah. So even though we don't count 5, we do get the last 5 items because we count from 0. So good that. And that's one of the reasons that programming in general uses counts 0 for all countings, right? And why arrays are counted from 0. Because, and this is important to know, what happens, this is a quick thing, but what happens when you do lesser or equal in programming? You're not doing one comparison, you're doing two comparisons, right? Because every time that you are doing that, like let's say you do lesser or equal, okay, you have to do two things per operation. You do, is this number lesser than, so you have to do, is this number, is 5 lesser than 6, right? And then you say, is 5 equal to 6? You have to do these two operations, and then you have to do those two operations for every iteration. So that basically just doubled your workload. Okay? Instead of just doing this, right? You have to do this and that. So by slashing that operation, you basically just cut your workload in half. Okay? That's why we use always, when you're doing this, you almost never try to use lesser or equal unless it's entirely necessary. Okay? You always use lesser. Okay? Because basically you're working twice as much. Okay? So okay, so now let's try to put the algorithm in there and see where I made a mistake. Because these things happen. But as long as we understand that, we can solve the algorithm and make it work. Okay? So let's go back to this. All right. Ba, 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 ba. So what have I done here? So I have the new index that I want, which is the length of the trail minus x. So as I said before, the length of the trail minus x. So that, and then I have the point. This is the point in the trail that I want. So I'm indexing this point that I have gotten. And then I am using that point. Maybe it's getting point from somewhere else. Maybe, no. So I don't know what's wrong here. But so now, because I don't know what's wrong here, I'm probably just missing something pretty simple. So let's take a look. So what I'm going to do is I'm going to print x to see what I get. Okay. So I'm going to print this x here and see what happens. So let's take a look. And it didn't work out. So, and it didn't print that either. Yeah, it should print out on the terminal. So let's see. It looks like, okay, so that does give me a clue of what happened. That does give me a clue. So let's see. Doesn't print. Yep. So maybe it does. So it starts with 0. Okay. Starts with 0. Maybe it's plus 1 there. Okay. That could be the case. So index. So it starts with 0 and 0 doesn't work out here. So let's do this plus 1. Let's try that. So what that tells me is that the subtraction that I'm doing there is going over the max amount of my max amount of items, right? So that would be the length plus 1, or no, actually what I want to do would be x plus 1. So x plus 1. And that probably makes sense because remember, so that this makes sense. I'll explain here why in a second. Just let me check if it.
Minus bracket x.
Oops, doesn't work. So no, that didn't work. So let's see. So that does print out 0. Let's check out what index is, what index looks like. So let's print out a couple things so we can check. So let's look up, we'll print self dot. So, and I also know that because my code is crashing here, right? So that means on my first iteration, my code crashes right here. Okay. So that tells me a couple of things. So self.trail, and I need to get the length from this length. Let's take a look. All right. I go back to this other guy. Then I run it. Let's see what I get. So 7. So I have 7 items. I have 7 items in there. And then I'm doing 7. And let's see what index looks like. Print index. All right. Oh no, over here. 8. So index is 8. So let's look into that. Something in my formula is long. So, but I mean that is just obvious, right? The length of the list is 7, and I am trying to reach 8. Okay, that's yeah. So then that means that I'm not doing something correct. So I am having minus, or maybe it's because of this. If I change this to that, because this turns into -1, and then minus minus equals plus, right? So yeah, so minus that and plus here. Yep. So x plus that. Yep. Because so yeah, I'm just adding 1 to it and then I'm turning into a negative number. Uh, print index. And I think that this still might not work, but just let me check. Let's take a look. Oh, no, there you go. There you go. Look at that. Look at that. Works perfectly.
2 lines. Well, 3 balls go down, and then one makes a snake.
Oh, because the other ones, so I could turn the other ones, so the other ones are different. So you haven't been on the other classes, but the other ones are just different entities. So if you take a look at so we did get into what that is, but I mean, I'm glad that so remember what I'm trying to do with this here is I'm trying to teach you what my problem solving method looks like. Uh, so yeah, but also before what we were going is into like what data structure I'm using here, or what I would say what coding paradigm I'm using. So I'm using OOP or object oriented programming, right? So if you take a look, so one of the balls is a snake. You see, it's a snake entity, or like it's a snake is part of the snake class, right? Which has different attributes, and the other 2 balls are just entities. So other balls are just entities, and also they don't move. For example, if I wanted to enable the movement of those, let me do that real quick. Although I don't know how to do that, but let me see. So maybe this will work. I'm not sure if it will work. So set right key. This works in other things, so I'm gonna just call it right arrow. Call it this one. Usually that's the nomenclature. Maybe it's not right. Left arrow. So set, and then here we're gonna set left key. Set that left key, and I need to call this ball 2. I need to call this ball 2, and then I need to enable trail. Oh, actually, no, I'm not going to enable trail. Do I need to do anything else after that? Snake, set key press. Oh, yeah, and I also need to send a little method here. So ball 2 dot set key press to key pressed. Let's see if this works. This might work. This might not work. Get out. Yeah, it doesn't work. There's no right arrow function. So let me just see if I can do that here real quick. So let's see event that key down. So print. Uh, this might be a little bit harder. Oh, because of that. Oh yeah, I would have to do some more modifications. No, I cannot do that right now. I forgot how I did that part. So actually, maybe it's up here. Key pressed. Oh, actually, yeah. So let me. Yeah, yeah. So let me do two things here, and I'll do that real quick. So let me see. So in here we can probably find it. So pi game event. What's it? Oh, pi game dot key underscore. So right parent right bracket or arrow. They don't have it. They probably have it as something, but I will have to set it to true or false for it to work. We could probably the thing is that we could there's some we could create and I would probably make a class out of that to basically create a method that switches that, but that is not too interesting right now. Uh Next time you come, you should bring a computer. But it's fine. I will make the catch up class for all the other stuff. I have a thing for that, but for now that's that. So but just know that I could put here different keys and the other things would move, okay? But we are right now the environment is not set for that to happen. Okay? But so as of now, look, so what do we got? We got this thing and beautiful. For example, another improvement that I could do is that like the trail starts from the beginning and then it just grows so as it's going up, you know? So that could be like the deletion function or whatever, but you see, very nice. So it works. So, but that's knowing that normally I do these things on my mind, but once you do these things enough times, you can do it too. You just have to like go basically through the steps. And if you know what everything is, you will be able to do this. Okay. Hmm.
Life then increases like in the same game, right? How the same game works, life
Increases, right? So,
it stays. Once you get eat something, it grows by one.
so for example, yeah, so now that brings us into the more interesting topic. So like how to do that. So for example, like we just did this, right? Now there is a very interesting thing about what you just said. So how do we start collecting those points? Okay? So let's talk about that for a second. So because in reality, it is very important that we understand that part to go into the next part, which is basically how to get the points, how to make the snake grow, right? Because it's actually pretty simple. Let me just do a quick thing real quick before I go back into the whiteboard. But what I could do is, for example, I could make another method here on the snake, okay? And I'm going to call it def, I don't know, I'll call it eat fruit, right? So, so, so in the snake game, right? When you eat the fruit, your snake grows, right? So def eat fruit. So I'm going to just say that. And how do I make that happen? Also, this should be
You have to
self dot snake length.
Doesn't make another entity.
Hmm? No, 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 no. The only thing that I have to do is start adding to this number here. So how do I do it? When I call this eat fruit method, all I have to do is self dot snake length is equal to self dot snake length plus one. Right? That's it. I'm just basically adding one to that thing. So now when I call it, that is the important thing. So for example, I'm just gonna do something kind of wacky here, just so you can see it here, but because I know that a couple things here, so I'm just gonna show you something. So self dot count equals 0. And I'm going to do another thing here. So if count, I might also increase the count. I'm going to delete all this stuff after, but self dot count is equal to self dot count plus 1. And keep in mind that this draw trail function is being called all the time, right? So self.count, if self.count is smaller than, let's say, 10, I'm going to say 20. If self.count is 20, I'm going to call the self.eat fruit, and I'm going to set self.count to 0. So basically this resets the counter, but every time I reach 0, I will eat a fruit. Okay? Every time I reach 20 on that counter, I'm gonna eat a fruit. Some problem here. Maybe because this thing, sometimes that happens. That's not a problem. It's all count. It's self.count. Self.count. Here, go here. Hmm. Uh, this might be, it's probably because of this part. If length is the other way around, if length of trail is smaller. Actually, this is wrong. I just say 5, whatever. There you go. Because that's growing either way. Uh-huh. There it is. Steps. Something there that I'm not doing correctly. Mm. Oh, because it's growing faster than that thing can keep up. Oh, I get it. Okay. So it's growing faster than that can keep up. So let me just change this thing. What thing? Let me change this thing to be, instead of that, let me change this to be like 40. That should work. See? Work. Yep. Maybe I'm self dot count. Oh, because it's happening every time. It said that count is greater than. Oh, okay. Okay. That should fix it. Yeah. But you see how it's still growing? So this is not pushable. Let me switch that to, instead of 20, let me switch that to 40. That was the reason that was happening. So it will look greater now. Did I close it? Yeah. It will be, over time I keep getting bigger, you see? Because I am gaining a little bit of length every second that passes. So, right? It is pretty simple, right? It is pretty simple, and but we don't want that, right? Like we're getting rewarded for nothing, right? So now, how do we make a reward system? Okay, so the reward system needs to be based in us eating the actual thing, right? So now, how do we do that? So now that is a big thing by itself. So let me get into